Hello everyone. Today let us discuss about paper chromatography. Paper chromatography is one of the chromatography techniques where we can use it for the separation of the components from a given mixture. Paper chromatography was first introduced by Martin and Sinch in the year 1943. It is a type of planar chromatography. Why it is known as planar chromatography is, in this case, the separation of the components is taking place on the plane of the paper. So that is the reason why it is called as planar chromatography. The principle behind this paper chromatography is two principles are involved in this. Suppose if we take the stationary phase and the liquid phase and the mobile phase both as liquid, then the principle involved in it is paper partition chromatography. That means in this, as we are using, the separation is taking place on the paper. That filter paper is generally what we take is a Whatman filter paper. So we know that the paper is made up of cellulose, and in that cellulose we find pores in it, a tiny pores. In those pores water will be held. So this water which is held in the pores of the filter paper will act as the stationary phase. So thereby we can say that the stationary phase is the liquid phase because water is acting which is present in the pores of the filter paper as the stationary phase. And the mobile phase is also used. What we use in this separation is liquid, that is the solvents. So organic solvents are used as the mobile phase. So both the stationary phase and the mobile phase used in this type are liquids. And the principle involved is paper partition chromatography. Now the separation of the mixture in this case takes place based on the differences in their affinity towards stationary and mobile phase. So when the sample is loaded onto the paper, which is acting as the stationary phase, and the mobile phase is run, then what happens is the components will get separated on the paper, on the surface of the paper. That separation is based on their affinity towards the both the stationary phase and the mobile phase. So more the affinity towards stationary phase, less the distance traveled by the sample, and more the affinity towards the mobile phase, more will be the distance traveled by the sample. So because of this capillary action of the pores in the paper, the separation takes place. The other principle involved is paper adsorption. So in this case, adsorption technique is used. Now here you can see both. Here the stationary phase is solid, whereas the mobile phase is liquid. So whenever we have solid and liquid phases, then the principle involved is adsorption. And generally the principle of separation is mainly partition rather than adsorption. Now these are the different steps where the paper chromatography can be done. So first step is we need to select a suitable type of development. In the development of this paper chromatography, we have different types: ascending, descending, radial, two-dimensional, etc. So first is we need to select the type of the development. Then selecting a suitable type of development, after that we have to prepare the sample. So how to prepare the sample? Suppose if the sample is solid, so we need to dissolve that sample in a solvent where that sample gets dissolved in the solvent, and then spot the sample on the paper. So next step what we need to do is, after preparing the sample has to be spotted or loaded onto the paper. So this loading of the paper can be done using capillary tubes or micro syringes. So what we need to do is, first, suppose if this is the paper what we have taken for the separation, we need to draw a line from the bottom by just from 1 centimeter distance away from the bottom of the bottom of this paper. Leave some distance and draw a line which we call it as origin line. Onto that origin line, we have to load the sample using the capillary tubes or micro syringes. After that, we have to let it dry just for a few minutes. Then we need to develop the chromatogram. So what we should do is take this paper and load it. We have to fix that paper in the chamber. This is known as chromatography chamber, paper chromatography chamber. So where the solvent is taken, the solvent here is acting as the mobile phase. Now the paper is dipped. We have to see that the origin line should be above the level of the solvent. Now, when the solvent, because of this capillary action, what happens? The solvent will slowly rises up to the paper. So as it is passing through the surface of the paper, it will interact with the sample. And slowly, because of the various affinities of the components present in the mixture towards the mobile phase and the stationary phase, after some time you can see different spots which are scattered like this. So thereby the separation of the components take place. And then after the development, so as the solvent travels up to 3/4 of the distance, what we have to do is we have to take that paper and then dry it. Then we have to detect the spots or the number of components which are present in the sample. Suppose if it is a colored components which are present, these three colored components we can see by our naked eye. But in some cases, there will be the spots or the components may be colorless. So in that case, what we have to do is you have to detect the spots using UV light or the iodine chamber. Now this is the solvent front. This is nothing but the distance traveled by the solvent from the origin. This is the origin where the sample has been loaded, and from that sample, after development of the chromatogram, we can see three different spots. That means there are three components present in the given sample. And this is the solvent front where this we have to measure the distance from the origin to the solvent front, and also from the origin to the different spots or the components which are formed on the paper. These are very helpful to calculate the RF values as we have seen in TLC. So RF is retardation factor. So how to calculate RF? RF is equal to the distance traveled by the component divided by the distance traveled by the solvent front. Suppose if you want to find out the RF of this one, the red spot. So what we do is RF is equal to the distance traveled by the component is 2. So 2 divided by the distance traveled by the solvent is 10. So 2 divided by 10. Then if we want to calculate RF for this purple spot, then it will be 6 by 10. Then for this blue spot, it will be 8 by 10. So in this way, after development of the chromatogram, we need to detect the spots and then calculate the RF values. Now, what are the solvents that we take as a mobile phase in this paper chromatography? So these are the solvents, list of the solvents in the increasing order of their polarity. All these we generally start from non-polar solvents. So N-hexane, cyclohexane, carbon tetrachloride, benzene, toluene. So all these are non-polar. So slowly it increases. So after that we generally take diethyl ether. Then we start increasing the polarity by taking chloroform, ethyl acetate, then alcohols, acetone, and high polar is water. So if the separation of the components is not taking place by one single solvent, then what we can do is we can prepare the solvent system by mixing one or two solvents. So we can mix either N-hexane with that of chloroform in 1:1 ratio, or N-hexane with chloroform with 1:2 ratio, like that. So we have to do all this by trial and error method. So keep on doing by taking the different solvents and then develop the chromatogram. So whichever solvent just helps in the separation of the components, so that solvent is selected as the suitable solvent. And what are the different types of modes of development in this paper chromatography? As I said, the first thing is we have different types of modes. One is ascending chromatography. Ascending chromatography is nothing but where you can see in this diagram, this is ascending chromatography. Just now I have explained you, that is we have to take a paper, load the spot. This is the original spot. Okay. And this is the chamber where it is filled with solvent. Only the level of here you can see the level of this solvent is still here. and the original spot is here. That means the spot should be always above the level of the solvent. And what we have done here, this paper is that is fixed from the top. Okay, so with the help of clips, it is hung inside the chamber. Now what we have to do is leave it for some time. So the solvent slowly rises up, okay, till it travels 3/4 of the distance. We have to put it like that. Then after that, remove the paper from these clips and then dry it and detect the spots. So in this case, why it is known as ascending chromatography is the solvent movement is moving up, that is from the bottom to the top. So as it is traveling in upward direction, solvent is at the bottom, isn't it? So solvent is traveling in the upward direction. So it is known as ascending chromatography. Then the other mode is descending chromatography. So what happens in descending? The solvent has to travel from top to the bottom. That is, it is traveling from towards it downwards. So this is in this diagram you can see that. In this case, what you can see here, the solvent is loaded in a trough. Okay, in this, solvent is taken at the top. There will be a trough where the solvent is taken. Then this is the paper. Okay, on the paper, now this is the origin line. So on that origin line, we are spotting. So here 4 samples are spotted, A, B, C, D. Those are the spots of the sample on the origin line. And you can see that this paper, edge of the paper should touch the solvent because the solvent has to travel on the paper. So because of this capillary action and the gravity, what happens? The solvent will slowly move downwards. Okay, so that is why it is known as descending chromatography. And here this paper is suspended in a trough, so you can see the clear traveling of this solvent onto the paper towards the downward direction. And then after it travels for some distance, you have to stop this development and then remove the paper and detect the spots. So only the change is in the traveling of the solvent. In the first case, the solvent is moving upward, so it is known as ascending chromatography. In the second case, the solvent is moving downward, so it is a descending chromatography. And the other type is a radial mode. Now in this case, what we do is we'll be taking a circular paper, okay, filter paper, Wattman filter paper. And what we have to do is we have to cut from the circumference. This is circumference of the circle of the paper, okay. So from here you need to cut till the center and then just an arc of that. So just cut the piece of the paper from the circumference to the middle, okay, like this. So if we cut, it is shown in this diagram, see. So if we cut like that, and this piece of paper which is there, which is still it is in the middle of the, it is joint in the middle of the paper, so that will act as a wick. Okay, it is acting as a wick. So that wick, what we have to do is after cutting, we have to place this paper on the petri dish. This is the petri dish. So the paper is placed horizontally on the top of the petri dish. Okay, this line, whatever you are seeing, that is, it is nothing but we are placing it horizontally. Now, when we place it horizontally on the top of the petri dish, and this wick, what you need to do is we have to suspend it into the solvent. Okay, because we are cutting this till here. So that piece of that paper has to be suspended into the solvent, which is present in the petri dish. Now this solvent is acting as the mobile phase. Okay, and the spotting is done on the paper. So where the spotting has to be done? It is done at the center. Okay, so you can see here sample is loaded at the center of the circular paper, and then what happens as we are suspending that wick into the solvent, slowly the solvent will rise up, okay, because of that capillary action, and it interacts with the components of the mixture present in the sample, and slowly you can see the separation where it is in the form, it is not in the form of spots. Here you can see the separation is in the form of concentric rings. Okay, so this ring is nothing but here it is written as solvent front. That means the distance of the solvent which is moved from the center to this part. So this is taken as the solvent front. Now the solvent will be flowing on all the sides. Okay. So when it is flowing towards the edges, towards the circumference of the circle, so as it is interacting with the sample, the components will get separated. And instead of detecting in the form of spots, you can find the components in the form of a ring, like this, a ring which is there here as a solvent front. Okay, so like this, suppose if we are finding only one ring, then we can say that there is only one component in the sample. So in this way, radial mode is done. Then the other important method is two-dimensional chromatography. So in this case, the development occurs in two directions. So how in two directions it takes place is first one is the normal type as ascending. So in this case, you can see the paper, okay, where this is the sample spot, or here it is written as drop of the mixture, and then it is placed in the solvent, which is acting as the mobile phase. So after some time, what happens again, the same solvent will interact with the sample and then separation takes place. So here you can see the separation after some hours later. This is the separation which is taking place on the paper. Now what we need to do is, so first thing is nothing but similar to the ascending type. Now what we have to do is, this is in one dimensional we have done. Now we have to rotate this paper to 90 degrees. Okay, 90 degrees clockwise, and then again place the paper in the solvent. Okay, so after some hours later, you can see the distribution of these spots in this way. So this two-dimensional chromatography is mainly done for the components whose RF values are very close to each other. So if we want the spots or the components to scatter on the filter paper, then the best method is two-dimensional. So first, as it is as that of the ascending type, we have to develop the chromatogram, and then just turn the paper 90 degrees and then place it in the same solvent. And after some time, you can see that scattering of the spots in this way. So this is two-dimensional chromatography. Now, what are the applications of paper chromatography? Now, this is very important type where we can use in number of applications we have. So first is to study the process of fermentation and ripening. So we know what is fermentation. So whether the fermentation is taking place or not, and then whether the ripening of the fruits is taking place or not, by taking the sample of that fruit and then placing it on the paper. Then to check the purity of the pharmaceuticals. So in all the different types of chromatography, this is again the same application where the purity of the components can be easily done or checked. To inspect the cosmetics, whether cosmetics are whether they are pure or impure. To detect the adulterants. So in all the food stuff, or nowadays all the food stuff is adulterated. So whether adulterants are present in that or not, we can use this type of technique and then detect the adulterants. And similarly, for contaminants in drinks and foods, in soft drinks and food material also, contaminants are present. So they can also be easily detected by paper chromatography. To examine the reaction mixtures in the biochemical laboratories, that is whether the reaction is taking place or not, that also we can check by paper chromatography. And also to determine dopes and drugs in humans and animals. So whether the humans are whether they are doped or not, that also can be checked by taking their blood sample, and then finding out whether the drug is present in their blood or not by using paper chromatography. So this is all about today's class. So we have seen what is paper chromatography, what is the principle involved in it, what are the steps required or we have to go through to conduct this paper chromatography, and different modes of development and the applications. Thank you for listening.